Hello friends, we are going to learn about HDFS. Hadoop HDFS. HDFS stands for Hadoop Distributed File System. So first of all, we have to learn about what is file system. So file system is basic method or data structure which an operating system uses to keep track of its file inside a inside a disk storage, inside local storage or disk. Suppose I have given a book to one person and the pages of same book in unordered way to some another person, and I have asked them to search for chapter number 34 act 2. Definitely the person who has book, he will go to the index and search the content in shorter time as compared to the person who has uh, the same pages of book but in unordered way. Therefore, we learned that without a file system, it is very difficult to search for a specific file. It is without a file system. It for a simple piece of information, it is very hectic job from where to start and where to end. File system is used to navigate a data inside a local storage or disk. So basically, we will learn about different file system. File allocation table FAT32, which gives 4 GB file limit and 32 GB volume limit. File limit is the maximum size of file that can be added to the file system, and volume limit is the maximum capacity which a disk or device can have. So it is volume limit is basic capacity or max storage, and file limit is the max size of file that can be added to the file system. So file allocation table is mainly seen in Windows 98 or 95. It is in earlier version, but Microsoft and IBM came with NTFS new technology file system which has 16 gigabyte file limit and 16 gigabyte volume limit. Similarly, in Apple, hierarchical file system gives 2 gigabyte file limit and 2 terabyte volume limit. As you can see in another version, Linux, in Linux it comes with extended file system with 2 terabyte file limit and 32 terabyte volume limit. Similarly with extended force file system, and then XFS is the high performance 64-bit file limit created by Silicon Graphics, which has 8 gigabyte file limit and 8 gigabyte volume limit. So now we will look the basic services of HDFS. HDFS basic contains two services, master services and slave services. So basically in master service it contains name node, secondary name node, job tracker. Slave service contain data node and task tracker. Job tracker and task tracker will be explained in our map reducing section. So I'm going to discuss all the basic things in HDFS services. So name node is the master node. Why it is called master node? Because it performs the management of storage space of data inside data node. It keeps track of file system. It stores the metadata of files inside Hadoop file distributed file system. For every name node, there is a corresponding secondary name node. Therefore, it is the responsibility of name node to send updated metadata at regular interval basis to secondary name node, because if in some scenario name node fails, then secondary name node comes into play. And job tracker keeps a track of job, and data node performs the actual groundwork of storage of data block inside node that is known as data node. Suppose if node are basically simple cheap commodity hardwares, or you can say these are easily available hardwares that can be our laptops or personal computer which store data. They are known as data nodes. And task tracker keeps track of tasks, these in slave services. So we have a specific communication between slave service and master services. Name node will communicate with data node, and job tracker will communicate with job task tracker. So actually there is a communication between master service and slave services with the help of some specific thing which is known as heartbeat signal. Heartbeat signal is just like a live message that I am still alive, which is given by task tracker to job tracker, or you can say data node also sends some block report to name node giving the updates of metadata to it. So heartbeat is a basic signal, or you can say a live signal, which is sent by slave part to master part. You can say data node to name node also at regular interval basis, and this is essential for the communication between master part and slave part. So now we look at the concept of HDFS. Files are stored across the cluster of computers. I will explain the complete process in my further slides. So files are stored across the cluster of computers. What are cluster? Cluster are multiple racks put together, and racks are what? Racks are multiple nodes put together. And nodes are basically cheap commodity hardware, or you can say easily available hardware that can be our laptop, personal computer. Therefore, I have mentioned that size is not fixed for nodes. And data node, as you can see, it performs the actual groundwork or storage of data inside it. And name node performs the management of storage of data inside data node. Or it keeps track of file system, or it manages all the basic functionality which is responsible for the functionality of data node. And as you can see, I have mentioned in earlier version of Hadoop, that is Hadoop 1.x, there is only one name node which controls over one rack or multiple racks. One name node controls over multiple racks. But in newer version of Hadoop 2.x, multiple name node controls over multiple racks. Okay, so as we have discussed about secondary name node is just corresponding node for every name node, and its name node always send up the updated metadata to secondary name node at regular interval basis. The main concept we have to learn as HDFS block size. Block size is what? A minimum size of block that can be read or write to the file system. Typically it is 512 bytes for disk, but for HDFS 1.x version it is 64 MB. So we will go through Hadoop 1.x version and we will understand this example. This is the example of replication process or normal process. So first of all, 192 MB data block is split into chunks as per block size. So we have discussed about block size of 64 MB. So 192 MB is divided into 364 MB. Then this 64 MB, as you can see, I have shown them with different colors. This 64 MB will create or generate its replica. As you can see, it will always generate 3 replicas, or you can say this create 2 copies, or including with this it has 3 replica. You can say that this 64 MB creates 3 replica, this 64 MB has created 3 replica, and this 64 MB has created 3 replica, and this 3 replica will be called as one input split, this will be called as one input split, and this will be called as one input split. Okay, so what are the overall process? Files are divided into chunks as per block size, and these chunks are also known as blocks. Then blocks are replicated into factor of 3. Then blocks distribution over cluster take place, and at one rack only max or max 2 replica can be there only in one rack. And this overall process is managed by name node. And I will explaining, and I'm going to explain this process with the help of further diagrams. With the help of these diagrams, as you can see, this is rack, single rack 1, rack 2, rack 3. These are data nodes. Basically these are computers or your laptops. Okay, and this is name node. This is the example of Hadoop 2.x, because here two name node is making control over 2 racks. But I'm just explaining with a simple example. Suppose this is the file of 192 MB is split it into chunks of 64 MB. Then these chunks are get replicated into factor of 3, then they get distributed over the cluster, and this whole part is known as cluster, as you can see. Then as you can see, one red replica is in rack 3, but other 2 replicas in rack 1. So max 2 replica can be in one same rack, but another one has to be in different rack. Therefore this is the smarter way of distribution of Hadoop. Why it is called smarter way of distribution? Because in case of rack failure or node failure, suppose this red or this rack 3 get failed to serve, so named node will be still able to put files together with the help of this red replica. Because if suppose this red replica is required and this red replica is failed, the another red replicas which are in rack 1 come into play. So named node will still able to put files together with the help of these red replica which are present inside rack 1. So about failure of any rack, another another you can say another rack or another replica or block, another replica came into play. Okay, so this is smarter way of distribution of Hadoop. There is few or rare cases when 2 racks get failed, because almost these things get cured up after first rack failure. Okay, so first, now we will discover HDFS architecture. As I have discussed about name node. Name node performs the management of storage space of data inside data node. It stores the metadata of files. Or it stores information about